So hey guys, so as I mentioned before, I converted to the iPad and I am writing notes on here to save paper. So let's go ahead and get started. So introduction to the atom and its continuing notes. Important facts and information. Each neutron and proton is one atomic mass unit. It is a very small fraction of a kilogram, about 1.6 times 10 negative 27 kilogram, like I mentioned before. And as you can see, this is an example of a proton, example of an atom, and this 12 is the neutrons plus protons included. It is the number of protons plus the number of neutrons, and it tells the mass of the entire carbon atom, and it can change from carbon atom to carbon atom. In this case, there are 6 neutrons, 6 protons, and 6 electrons orbiting. Remember, protons is positive, neutrons is neutral, and electrons is negative. One proton is 1,836 electrons. Remember, mass of nucleus, the mass of the electron is really counts as the mass of the atom. So here, as you can see, this is not an atom, but this is kind of like the periodic table. This is the periodic table, and this is one of the elements, which is oxygen. This number 8 up here is the atomic number, meaning the number of protons. Here, this number means the atomic weight of oxygen. And it's the average number of oxygen you'll get when finding all types of versions of oxygen and averaging out the electrons. Isotope is the same element with different number of neutrons. The nucleus is 1 out of 10,000 volume of the atom. It is very small, 99.999% free space. There's 2 major forms of carbon, but this one is less scarce. This one is scarce, but this is not that scarce. As you can see, there's 14 here, 6 neutrons, but there is 8 neutrons and 6 protons here. Most things to look at aren't really solid. They look solid because of how light reflects on them or the forces that repel us. And if you weigh these two out, they average out to 12.0107. Atomic and automatic mass and isotopes. So this is based on radioactivity. The property of atom, they have unstable nuclei. Radioactive isotopes occur often. Nuclei. Eventually release subatomic particles that give off energy in their process to become more stable. I forgot to continue writing stable there. They differ in the elements are radioactive and there are also non-radioactive versions. These are types of isotopes. They differ in the number of neutrons, and radioactive isotopes often occur in nature. Moving on to atomic number, atomic mass, and relative atomic mass. The number of protons in an atom equals the atomic number. You can find a neutron by adding by the number of protons, the adiabatic number from mass number. Adiabatic net mass of atom is the total mass AMU. It is slightly different, but very close to the mass number. Relative atom mass is the atomic weight. It is sometimes called the atomic weight. And extra versatile objects, asteroids and meteors, might have different isotopes. The average of atomic masses of all different isotopes in the sample equals calculated for all naturally occurring isotopes of each element. The atomic number is the number of protons here. This H is a symbol, this is a relative atomic mass, and this is the name of it. So some isotopes are stable, but others have to kick out subatomic particles. And why is everything like this? Slimy. So this process is called decay, but it is when the subatomic particles to be more simple, so they lose energy because they are not originally stable. And these isotopes are called radioisotopes. And it could cause change in the number of protons in the nucleus. Half of isotopes life is actually used to the process of decay. And carbon naturally is presented in the atmosphere in forms of gases, and it exists in 3 isotope forms: carbon -12, it's used in 9% of the time; carbon 13, which is 1% of the time; and these carbon 14, which one is that one? Carbon 12 and carbon 13 are stable, and carbon 14 radioactive, meaning not stable, is tiny amounts. Carbon 14 in plants is equals carbon 14 in the air, when plants pull out carbon dioxide from the air to make sugar. Carbon 14 in animals is eating plants in the carbon 14 in animals that are eating plants is the atmosphere carbon 14. The fraction of isotopes that haven't been in the process of decay can be discovered through the rations of carbon 14 and carbon 12. Decaying can be used to date former living objects to the object of the same ratio. Is the starting equals the starting concentration of objects. Some elements have isotopes with different half-lives. So as you can see, this is kind of like a timeline of carbon 14. So as you can start here, it's the starting amount, and there's a little carbon 14 remaining, and then 50% of the starting amount, and it changes to a different carbon. Carbon 14 decaying because nitrogen 14, so from carbon 14, it now can become nitrogen 14, and this is half of the lifetime. Moving to shells, subshells, and orbitals. So this is not the full video notes, but